Come in.
Hunter, the DNA test for Nate Dubinsky's alleged Christmas thief has come back positive.
Oh my. Let's get on it. Hello and welcome to a Discrete Structures Christmas special. I'm Hunter Gates.
And I'm Joseph Gu.
And today our topic is probability. We're going to be working on a problem adapted from Homework 6, Problem 5. And it reads as follows. Someone stole Nate's Christmas presents. We have a list of 10,000 people on the naughty list. Based on Santa's experience with this before, he estimates that the probability that someone on the naughty list took them is 0.7. After examining the crime scene, Santa finds a half-eaten candy cane and decides to test it for DNA. Lo and behold, he finds a match with someone on the naughty list. We know the probability that any two random people's DNA matches is 1 in 5,000. The thief is sneaky though. 1 out of 8 times, the thief will fudge the DNA test and get past it without being identified. What is the probability that the thief is actually on the naughty list? Well, let's jump right in.
To obtain our probability for Nate Dubinsky, we will use Bayes' rule. Bayes' rule allows us to calculate the probability of an event A given B based on what we know about the probability of B given A. So let's set up some events. Let on list represent the event that the thief is on the list. Let positive tests represent the event that the DNA has matched with someone on the naughty list.
So that would look like this. So let's start cracking this case.
To fill in some numbers, we know that the probability of a positive test, given that the thief is on the list, is 7 out of 8. Because if the thief is on the list, we will test him, and he will only be able to escape the test 1 out of 8 times. So 7 out of 8 times, the test will come back positive. The probability that he is actually on the list is 0.7 by Santa's estimations.
And we need to divide this by the probability that we get a positive test. And in order to find a positive test, we know that it's 1 minus the probability that we don't get a positive test. And that it looks like this.
To expand out the probability of not having a positive test, that is equal to the probability of not having a positive test given that the thief is on a list plus the probability of not having a positive test given that the thief is not on the list.
So let's keep cracking this. With this in mind, we can then fill in some values.
Let us further expand out the probabilities in the denominator. First, the probability that there is not a positive test given that the thief is on the list. If the thief is on a list, there's one thief and 9,999 innocents. The probability of a single innocent testing negative is 4,999 over 5,000, because as given in the problem, there's only a 1 in 5,000 chance that the innocent will match with the criminal DNA by accident. So 4,999 over 5,000 raised to the power of 9,999 gives us the probability that all the innocents in this case test negative. Now multiply that by the probability the thief tests negative, which is 1 out of 8. Because 1 out of 8 times, they are able to fudge the test and get past it.
We then have to add the probability that we get a negative test given the thief is not on the list. This means that we have to multiply the probability of an innocent testing negative by itself 10,000 times. After simplifying our values down, we come to the result of 0.7224. This can further be simplified down to 0.7225, which means that there is a 0.7225 probability that the thief is on the naughty list, which is higher than the original estimate. So what can we get from this information? Well,
there is now a 0.7225 probability that the thief was on the naughty list, which is higher than the original probability, which was Santa's estimation before we knew there would be a positive test.
We used Bayes' rule to find the conditional probability based on the reverse conditional probability.
In the end, the thief has felt bad and has since come forward.
So Christmas is saved. Thank you and happy holidays.
Wait, where are you going?
Well, I gotta go return Nate's gifts. It's Christmas.
That's sure nice. I'm sure he will boost our fundies grades.
Yeah, I hope so.